everyone. So in today's lab, we're going to be looking at measuring the dissolved oxygen content of some water samples. So there are many different ways that we can measure the oxygen content in water. We can use things like electrodes, probes, oxygen meters, but today we're going to be doing a titration. And even though titrations may seem time-consuming, it does give us very accurate and precise results. So it is beneficial to use a titration if we have the time to do so, which of course we do today. So today we're going to be doing a Winkler titration, which is an iodometric titration, meaning it uses iodine. And in this method, the oxygen in the sample is capable of oxidizing manganese. So it oxidizes manganese, and then in that higher oxidation state, the manganese can oxidize iodide to iodine. And then we do a titration to measure the amount of iodine in our sample. And that amount of iodine that we determine, that's equivalent to the amount of dissolved oxygen in our sample. So that's the basic principle of how Winkler titration works, and you can see more details on that in your lab manual, of course, as well. So because we're titrating with sodium thiosulfate, we need to know the exact concentration of the sodium thiosulfate. So we're going to start by standardizing a solution of sodium thiosulfate to get the exact concentration. Okay, so we're ready to start the standardization of our sodium thiosulfate solution. So I've already diluted the stock solution of thiosulfate, the solution C. Okay, so with solution C, we've diluted down to 0.0125 molar. So we know that's its approximate concentration because I took 125 milliliters of the stock solution C and I diluted that down into a 1 liter volumetric flask. So it is approximately 0.0125 molar. Okay, so I've used this solution to fill my burette. So that solution is in our burette right now, ready to go. Okay, so we're going to standardize that to determine its exact concentration. So to do that, we're going to use this Erlenmeyer flask, or a conical flask. We're going to add to it, first of all, 2 grams of potassium iodide. So I have 2 grams of potassium iodide already weighed out here. I'm going to add that to the flask. Okay. Now we're going to add 150 milliliters of distilled water. So I've already filled that up in our graduated cylinder to 150 milliliters of distilled water. So we're going to add that to our potassium iodide in the flask. Just make sure that's dissolved. Now we want to acidify it, so we're going to add sulfuric acid to it. So this is solution H. It's 1 molar sulfuric acid. So we're going to add 5 milliliters of sulfuric acid to the flask. So I'm going to use an Eppendorf pipette for that. So this Eppendorf pipette is set to 1,000 microliters, which is 1 milliliter. So we're going to do that 5 times. We could also use a regular volumetric pipette for this as well, but Eppendorf is just as accurate as that. So that's our 5 milliliters. And now we're going to add our indicator, which in this case is a starch solution. So this is a starch indicator solution. So we're going to add just a few drops to our solution. It's maybe about 5 drops. So after the indicator solution, now we're going to add our potassium iodate solution. So this is a diluted potassium iodate solution. So we started with our stock solution, which was solution F, and I diluted that down to 0.0100 molar. Okay. So I took 25 mils of the original solution and diluted it down in a 250 ml volumetric flask to give us a 0.0100 molar solution. So now I'm going to take 10 mils of that and add to our flask. I'm using a volumetric pipette again to do this. So we want to keep our volumes very accurate. Eye level. There we go. Let that pour in. And you'll notice we're getting a greenish color solution with our potassium iodate. Slightly bluish green, that's the color of the starch indicator that we're seeing there. So that's to be expected. And now we're going to titrate that with the sodium thiosulfate that's in our burette. Okay. So let's start our titration. And again, like any titration, we'll start slowly because we don't know how much it's going to take. So it turns a little bit more blue. So we get closer to the end point. And what we're looking for is all of that blue color to go away, and we'll be left with a clear, colorless solution. So blue color is the color of the starch indicator. Very close to the end point here now. Probably one more drop. I'm going to rinse down around the sides of my flask before I go any further. Just make sure that all of that thiosulfate's down in the solution. There isn't any left up around the sides of the flask. I want all of that blue color to be discharged from the solution. There we go. So now we have a clear, colorless solution. So that's the end point of our reaction. Okay, so that's the titration we're going to use to standardize our sodium thiosulfate, and that will allow us to calculate the concentration of that sodium thiosulfate, and then we're going to use that to titrate our samples. Okay, so now we're going to move on to our samples. So this is a sample of water from Kent's Pond, and it's a surface water sample. So we just took the bottle and let the water pour into it from the surface of the lake so that we get the water that's at the top, okay? So first thing we want to do is fix our sample so that we can analyze it when we are ready. So this is a step where we actually add the manganese. So we're going to start by adding manganese sulfate. So this is our manganese sulfate, solution A in your lab manual. We just poured some out in a flask, so it makes it easier for me to transfer. And we use 0.5 mils for every 100 milliliter of sample volume. So we have 300 milliliter bottles, so we're going to use 1.5 milliliters of the sample. Okay. So I have an Eppendorf pipette, so I have that set on 1000 right now, so that's 1 mil. I'm going to add 1 mil first. Adding it below the surface of the water. Okay. Now I'm going to change my Eppendorf volume to 500. And I'm going to add another 500 microliters, so that's for a total of 1.5. Okay, so below the surface of the water. Okay, so that's our manganese sulfate. And the next reagent that we add is the actual Winkler reagent. So that's reagent B, and it's the same amount, so 0.5 for every 100 mils of sample. So again, we're going to add 1.5. So there's 0.5. I'll replace that tip. And 0.5. And you can see that that certainly changed the color. Whoops, wrong bottle. Certainly changed the color of our solution. So these are fixed now, so we can store these until we're ready to do our sample analysis. So I'm going to fix the rest of the samples, and we're also going to do some extra samples that we're going to use for BOD, biological oxygen demand, that we're going to test in the next lab. So those ones we're going to store in the incubator for 5 days. Okay, so we've allowed our sample to sit for a few minutes to allow the precipitate to settle to the bottom. So you should be able to see a brown precipitate there at the bottom of the flask. So now we're going to acidify it. So we're going to add reagent E, which is sulfuric acid. So it's 50% sulfuric acid, which is reagent E. So we're going to add 1 milliliter of that to our flask. So again, I'm using the Eppendorf pipette for that. Okay, put the stopper back on, and now we're going to mix it. And you start to see that brown precipitate dissolve. And what we should be left with is a yellow, orangish color of the free iodine. There we go. There's still a few little particles in there, but that's the debris from the water. There we go. So the precipitate is all dissolved. So now we're ready to start our titration. So I'm going to take 50 milliliters from this sample and transfer it to an Erlenmeyer that we can use to titrate with the sodium thiosulfate. Okay, so I've taken 50 milliliters from our sample bottle, put into a clean Erlenmeyer flask. You can really see the nice yellow color of the iodine here now. So now we're going to titrate with our standardized sodium thiosulfate solution. So the sodium thiosulfate is still in the burette. So we'll start our titration. So what we're going to do with this titration is we're going to add sodium thiosulfate until we get a pale yellow color, and then we will add our starch indicator at that point before we continue our titration. Okay, so that's our pale yellow. So at this point, we're going to add our starch indicator. A few drops of starch. And we're expecting it to turn blue. There we go. So now that we've added the starch solution, we're going to continue our titration. So I haven't taken any readings at this point because we're still going. Okay, so we only took our initial burette reading. We're going to continue our titration until we get a colorless endpoint. So a clear colorless endpoint is what we're looking for. So all the blue color is gone. It should not take very much at this point. There we go. Clear, colorless, and that's our endpoint of our solution. So the volume of our titrant that we used there, our sodium thiosulfate, we're going to use that in our calculations to determine how much iodine in the solution, and that in turn then can be used to determine the amount of dissolved oxygen in your sample. Okay. So again, you'll be provided with the results for the rest of the samples, okay, and for any replicates that you do. And then next week we're going to come back and test the samples for the biological oxygen demand. Thanks for watching. I'll see you in the next video.